Hello, and welcome to a little video about the KC6 quiz review. Let's get started. For number 1 and 2, we are going to write an explicit formula for the sequences. So let's write down the formula. It's an equals a1 r n minus 1. a1 is our first term. That's easy to find. a1 is 1. Now, in order to find our r, our common ratio, we're going to take our second term and divide it by the first term. So we're doing 4 divided by 1. 4 divided by 1 is 4. Perfect. Let's make that green. So 4, and then up top, n minus 1. Same idea for number 2. So a1 is our first term. Our first term is 7. 7. Next, I need to find r. To find r, I do second term divided by first term. I don't really have room here. I'm going to write it right there. Negative 10. So I did negative 70 divided by 7, and I got negative 10. So that's our r. And n minus 1 is its power. All right. Next, let's take a look at number 3 and 4. For number 3 and 4, we're going to write the explicit formula in function form. Here is the function form. Now, this is just a regular a. It's not a1, so it's not the first term. I'm going to rewrite that. That was ugly. There we go. Okay. So the cool thing here is that our r stays the same, so that's kind of nice. We do need to find a. A is our y-intercept. Now, the easiest way to find a for all cases, for all y-intercepts, is to do 10 times 1/2 to the power of 0 minus 1. So we plug in a 0 into n. And we do this because every y-intercept starts with 0. And that equals, plop it into your calculator, 20. Okay, so we've got 20 times 1/2 to the power of x. Now, another way to get that 20, the shortcut is to do outside number divided by inside number. So we could also, whoopsie doopsie, we can also find a by doing 10 divided by 1/2. All right, that's another way to do it. That only works for exponentials, so plugging in 0 works for everything. So it's a good habit to form. Okay, let's do the same thing here. So we already have our common ratio. All we need to find is our y-intercept. And again, in your calculator, you can do negative 4 divided by 1/5. However, this is the way that works for everything. You plug in a 0 instead of n. Do this in your calculator, and you will get negative 20. So negative 20 times 1/5 to the power of x. Okay? Number 5. Let's compare the two exponential function. Which has a greater constant multiplier? Now, constant multiplier is our ratio. Because it's being multiplied constantly. So different names, but still the same thing. Okay, for function b, I can see it right away. Here it is. R equals 9. Now for function a, we're going to have to figure out what r is by doing second term divided by first term. That goes into your calculator, click, 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 and we get an answer of 10. So here we have that r equals 10, r equals 9. Function a has a larger constant multiplier. When I say here, explain your reasoning, I want to see your math. I want to see that you did the division. That explains it to me. Not necessarily need a sentence, but your work is the same as a sentence, right? You're writing r equals 11 divided by 11 over 10. That's you telling me that r equals 10 and quite obviously 10 is larger than 9. That's why you pick function A. Let's do the same thing for number 6. So I can find the constant multiplier, the ratio real quick in function B, r equals 4. Here I need to do to find r, second term, so 3 divided by first, that's 3/5. 3 divided by 3/5 is 5. So here r equals 5. Which one's bigger? Function A is bigger again. Number 7, 8, 9, and 10, we're going to take 7/5 to the power of x, and we're going to translate it in different ways. Now, the hard part is remembering where to put those translations. Now, 7/5 to the power of x, moving 10 to the right, right and left go up by the exponent. So, 10 to the right gives us a minus 10 by the x. Number 8 asks us to do 10 to the left. 10 to the left is going to be in the exponent, but this time it's going to be a plus 10. For up and down, these exist in different places. For 7/5 to the power of x, 10 units up, this is how we're going to write it. 7/5 to the power of x. The plus 10 goes outside of our function. So it's not floating up there, it's a big number to the side. Next we have 7/5 being to the power of x being translated 10 units down. That's going to happen outside of the function minus 10. Lastly, number 11, translate the graph 2 units down. We're quite literally going to take this graph and move it down 2 units. So this looks like it's -3 right here, so we're going down 1, 2. New point. 1, 2. New point. 1, 2. There's our new point. So here is our new function. Why did that come out all squiggly? You saw that? That was weird. Let's try that again. Okay, very weird. I don't know why it's being squiggly, but that's okay. We're just going to pretend it's nice and solid. Maybe if I color it in? No? Okay, one last try. Okay, that's just crazy. What if I do it from this end? What? Okay, I give up. But you know, you see the point, right? We're translating it, so we're moving it 2 down. If you have any questions about the quiz or the review, please let me know. Otherwise, have a wonderful rest of whatever day it is for you. Bye!